Welcome to K Series Cybersecurity Lecture Notes, starting with Computer Network Basics Part 2. Here, as you can see in my picture, the diagram shows a mapping equivalence of TCP/IP layers with corresponding OSI model. As you can see here in the picture, our TCP/IP model is of 4 layers, whereas our OSI model is of 7 layers. Starting from the upper layer of application layer, the TCP/IP model has the application layer, which is further split into 3 layers of OSI model, which these are session layer, presentation layer, and application layer. Host to host layer of TCP model works as same as the transport layer of OSI model. Similarly, the internet layer of TCP model works similarly as the network layer of OSI model, whereas the network access layer of TCP IP model works just like the physical and the data link layer. Our OSI model further splits this particular TCP IP model into more segregated and more defined layers. Moving on further, our protocols of TCP IP stack are file transfer protocol, simple mail transfer protocol, telnet for remote login, then HTTP hypertext transfer protocol, TCP, UDP, then IP, ARP, ICMP, network interface. See here, at application layer, FTP, Telnet, SMTP, HTTP all work. This particular layer is dependent on the lower layers for accuracy and efficiency of delivered data. Here, we define rules for implementation of network applications like FTP. For all the file transfers, we use FTP. For remote login on any other computer on the network, Telnet is used. For mail transferring, we use SMTP. For web browsing, we use HTTP. At transport layer, we have TCP, that is Transmission Control Protocol, and User Datagram Protocol. In Transmission Control Protocol, services are connection oriented, a dedicated connection is established, whereas in User Datagram Protocol, it is a connectionless service provider. No dedicated connection is established over here. No sequence segmentation is there. No acknowledgement. Whereas in TCP, we do have segment sequencing, we do have acknowledgements also. Let me show you further how it works. See here. As you can see here on my screen, both the TCP, UDP protocols work for our computer networks. Moving on further, internet layer of TCP IP model is a collection of specifications, methods, and protocols in the IP suite, primarily responsible for transportation of packets from one host to the other. Internet layer protocol uses IP based packets. Now, what are these IP based packets? We have two versions of IP based IP versions. IP version 4 uses 32-bit addressing, which limits the address space to 2 raised to power 32. It basically is of 4 octets of 8 bits, that is 2 raised to power 32, and we can assign addresses in IP version 4, whereas in IP version 6 we uses 128-bit addressing scheme, that is the total addresses. Here we have 8 octets of 128 bits, that is 2 raised to power 128, which approximately to 3.4 into 10 raised to power 38 addressing scheme. These days we use IP version 6 generally to provide IP addressing to each and every device on the computer network. Then come see here, IP version 6 addresses are in the hexadecimal format. As you can see here in my picture also, hexadecimal starts from the 0 and goes up to alphabet F. 0 from F. Notation from 0 to 15, and the hexadecimal notation is from 0 to F. TCP IP link layer. Here we use ARP, that is Address Resolution Protocol. What exactly it is? Address Resolution Protocol, it looks for the hardware address, that is the MAC address of a host, from its known IP address. Basically, ARP maps the IP address with the MAC address of the device. ARP maintains a cache table in which a mapping of MAC addresses to IP addresses are stored. Here we use border gateway protocols also, that is BGP protocol, which is a routing protocol used to exchange data and information between different network systems. BGP maintains routes to various host networks and gateway routers on which the routing decisions are made. BGP is often referred to as the reachability protocol because it is responsible to form a full-fledged path between the source and the destination. It is responsible for routing basically. Now comes the process of data encapsulation. See here at the data link layer, we have frames and we add frame header into it. At the network layer, IP header is added with our data payload. At the transport layer, we again put or encapsulate our data with the UDP header. And at the application layer, we simply deliver our data to the end user. We have different types of network devices to communicate from one network to the other, from one computer to the other, like repeaters, hubs, bridges, routers, gateways, switches. Now let me show you how repeaters work. Repeaters work at the physical layer. These repeaters revive the weak signals over the network. Repeaters, if I say weak signals, here weak signals get bitwise copied and regenerated at original strength. It is typically a two ports device, and repeaters do not amplify the signal, do not enlarge the signal. They simply strengthen the weak signals, bitwise copied it and regenerate at the original strength. Hubs also work at the physical layer. These are repeaters with multiple ports. It usually cannot find the best route to be used for data packets. These hubs are of two types: active hubs and passive hubs. In active hubs, there is a power of built-in power supply. It cleans up, enhances and transmits the signal over the network, typically used to extend the net distance between the network nodes. Whereas in passive hubs get lines from nodes and power supply from active hub. No cleaning and enhancement of signals is done here, and cannot typically be used for the purpose of extending the distance between the nodes. Now comes the bridges. Bridges work at the data link layer. A bridge is similar to a repeater and has an ability to filter just the required content based on the MAC address of the source and the destination node. Here, used to link different LANs that work on the same protocol. A bridge has one input and output port each, that is two ports per device. Types of bridges are transparent bridges, we have source routing bridges. Then comes the routers. Routers work at network layer. Routers directs data packets on the basis of their IP addresses, interconnects LANs and WANs with each other. Routers also responsible for referring data routing decisions, and these routers maintain routing table to get updated on the fly. That is, whenever the data is on the path, it is updated, its route is updated in the routing table of that particular router. Now comes the gateways. Gateways perform from the layers 3 to layer 7. Gateways connects two networks that may be working on different underlying networking models, performs the role of an interpreter between two systems, often referred to as protocol converters, typically capable of operating at most of the network layers. Gateways possess more complexity as compared to switches and routers. Now, Switches again work at the data link layer. Switch is fundamentally a bridge with multiple ports. It has a buffer also for temporary storage and designed in such a way that it elevates its efficiency in performance. Usually are capable to perform error checking and before forwarding the input data ahead. Switches are efficient due to the quality of blocking the erroneous packets and capability of selective forwarding of good packets to the destination. That's all in this video. In my next video, I will cover the computer network fundamentals part 3. Thanks for watching.